Lesson 20, page number 98. Simplification of radicals and lines parallel to a given line. Simplification of radicals. Again, this is going to be old stuff for you.
Again.
There's your first rule. Any number times another number equals, multiply them together. Okay? That's not too bad. The opposite is also true. I can take the square root of 6 and rewrite it as the square root of 3 times the square root of 2. I can take the square root of 27 and write it as the square root of 9 times the square root of 3. Okay? So you can go either direction there as far as your radicals are concerned. What's that? No, it was a 3, but the smartboard just made it a 1 when I put my marker up there. So, all right, which brings us, yeah, something's going goofy because it's not erasing very quickly. So 3 times the square root of 50 minus 5 times the square root of 200. See? There we go. All right, a couple things as far as radicals are concerned is you cannot combine radicals, you cannot add or subtract radicals if the base number, the root, or I'm sorry, the radicand, I think is what it's called, the 50 or the 200, if they're not the same. The only way you can add and subtract radicals is if you have 3 times the square root of 2 plus 6 times the square root of 2. Now I can add the 3 and 6 and get 9 square root of 2. When you're adding and subtracting radicals, it's kind of like the radical is a variable, like it's a letter. If we had 3x plus 6x, you get 9x. It's kind of the same thing with the radicals. Okay? So when you're adding radicals, you never add what's under the square root sign. You only add and subtract the numbers in front of the square root or outside of the square root. So when we're given something like 3 times the square root of 200, we can't figure that out unless, of course, we simplify the radical first. Lots of people have a lot of different ways to factor or simplify radicals. The way I do it is find 2 factors of 50. I mean, there's a lot of factors of 50. If you look at just 50 itself, there's 2 times 5 times 5. Okay? But I don't really care about 3 factors. I'm interested in 2 factors of 50. So, my options are 2 times 25 or 5 times 10. Those are my only 2 options for 2 factors of 50. When multiplied together, give me that 50. But what I'm looking for are 2 factors of 50 where one of them I can take the square root of. So I'm not going to use the 5 and the 10 because I can't take the square root of 5 or 10. So I'm going to use the 25 and the 2 because I can take the square root of one of them. So I'm going to rewrite the square root of 50 as 25 times 2. What is the square root of 25? 5. What number times itself gives you 25? And the square root of 2 is left over because there isn't one.
Wait, couldn't we have just gone the other way and put like the couples outside?
If you had
If we had the 5 on the, yeah.
like that,
Yeah.
you've got 2 couples, they go outside,
Yeah, can
and the
we
2
do that?
stays in. Yeah,
Okay.
works the same way.
Where did the 3 for
Ooh, scared me.
that go?
I haven't done anything with the 3 yet.
Okay.
Yeah, either one. I know Tristan teaches the couple thing, but whichever way is the easiest. For me, this way is easier to do if you're going to do it in your head. Because like 200, I can look at it as, 102, so 10 times the square root of 2. And you just kind of, whereas the couples, when you have bigger numbers, you're going to use the couple thing because that's the only way you can do it. So, All right, so Kendra was asking what happened to that stupid 3 up there. Well, the 3 just kind of drags along there. And once I get my radical simplified, then I tag the 3 on there and I multiply. So 3 times 5 times the square root of 2 is 15. So 3 square root of 50 is the same as 15 square root of 2. And one way you can check that, at least to me it's fairly easy, is if you square the 3, or square whatever number's outside of the box here, what is 3 squared?
9.
And multiply it times 50, it's 450. If I square this,
You're on your own.
times whatever's in the radical sign,
Oh, that's cool, yeah.
they're both the same numbers. So I know I'm right.
Does that always work?
Yes, always works. So you square the outside number, multiply it by what's inside, and it's an easy way to find out if you're on the right track. All right, so I've got 15 square root of 2 there, when 3 times the square root of 50 is simplified. Doesn't really look like it's very simplified, but what I'm trying to do is get my radical as small as I can. Actually, what I'm trying to do is get my radicals the same so I can actually subtract. So let's get rid of some of this mess here so it's not.
Goodness.
Okay. So 5 square root of 200. We still have our 5. And then we have the square root of 2 numbers multiplied together, give me 200. And I can pull what out? Take the square root of one of them and pull it out. So, or like Elias was saying, make that 10 times 10, pull the couple out. Fortunately then,
Oh,
those are both square root of 2. That won't always happen. And sometimes it helps to know that you want a square root of 2 so you know what numbers to start playing with. So if I've got 200 and it's like, wow, that's 20 times 10. Let's see, 25 times 8. Take the square root of 25. 100 times 2. You know, you've got all of these different ones that you can use there as factors, and every one of them will work. It's just if you find 2 where you can take the square root of one of them, your work is simpler. So for instance, I pulled 2 out of here is 100 and square root of 2. Pulled the 10 out and I get 10 square root of 2 is the same as the square root of 200. Now if you do what I was saying before, square this, you get 100 times 2, you get your 200 back. So you know you're on the right track when you simplified it. All right, but I could also use 25 times 8 because I can take the square root of 25. But the problem is I can simplify both the 25 and the 8. So now what I've got is a 5 here and a square root of 8 here, but this breaks down to what? 4 times 2. And you can take the square root of 4. So now I've got 5 times 2 times the square root of 2. Now I have 10 square root of 2. So I get the same thing, but I had to go through a lot more steps to get there. So the key thing is to find one number you can take the square root of and the other one you can't. It can't be simplified, preferably a 2 or a 3 or a 5 or a 7, you know, something where you can't take the square root of. Okay, you're looking at me like you're going way too fast and I'm not following all these strange things.
what's the ending answer?
The end is going to be, well, we have that right there. So 15 minus 50 is what? Okay, let me give you one to try.
Oh. Going on 10 minutes.
Notice I have multiplication signs up there, so the addition and subtraction rules do not come into play here. You just multiply across.
Wait, what?
You're not adding or subtracting, so we don't care if the number under the square root sign is the same. You just multiply.
So you're multiplying even the ones underneath the square root?
Yes. So outside of the square root, what do we have?
24.
Inside the square root sign? 72. Okay, most of you are happy at that point. I'm not.
Makes me happy.
It's not simplified. Square root of 72, you're like, wait a minute, there's got to be something I can do with that. When you start thinking of factors of 72, 72 is one that has a lot. So, can you think of two numbers
8 and 9.
multiplied together that give me 72, that only one of them can be simplified? 8 and 9 work, but two of them, both of them can be simplified. Madison?
2 and 36.
2 and 36.
I do that.
Now the 8 and 9 will work, Elias. It's just going to take you more steps to get there. Okay, so the 24. So now we look at our 36. We pull out a 6, and the 2 stays in there. And 24 times 6 is a gross. You guys know the term for 144 is a gross? 12 dozen. I have no idea why you ever need that, but
We figured that out in 4th grade.
if you're a baker, what's a baker's dozen?
13.
Why?
He makes one for himself.
That's
what I thought.
That's it.
I thought that forever.
I never got that. It's like, really, why is a baker's dozen 13?
Well, in
Figured that
case
out.
one of the eggs is bad
He
or
makes
something
one
and he
for
needs a
himself.
dozen.
Now, how about back in Bible times with the Apostle Paul talking about getting whipped 40 minus 1? Anybody know why he got whipped 40 minus 1? Caleb?
Supposedly 40 is what kills you.
The thing is, that's one perspective. The other perspective is the Roman guards, if they whipped you more than 40 times, you could be killed for the torture being too harsh. So they always gave one less than 40 in case they miscounted. But I've heard both versions. What Caleb said.
Wait, what?
Yeah, I heard-
The guy getting whipped.
I mean, you're whipping somebody. How many times are you counting?
61. Ooh, that was nasty. Oh, what was I on? Oh,
Yeah.
God.
What's
Sorry.
in my eye?
Were you counting? I wasn't.
Okay,
No, I was counting.
what are we going to do with that?
Flashes.
There was 40.
Yeah. There's only like 5 lines on it.
Okay, you have a couple choices here. You've got the distributive property, or you can subtract what's in here first.
No.
But you can't,
No, you
because they're not common radicands there.
Radican.
So, we do distributive property. What do we get?
can.
8 square root of 9 minus 4 square root of 18.
Okay. At that point, we need to look at each one of our terms, see if we can reduce it to the same square root. Square root of 9 reduces to what?
3.
So 8 times 3 square root of
Nothing. Nothing.
nothing. Good. So, no square roots. Minus 4 times square root of 18.
3.
We've got 3 and 6. Can I take the square root of either one of those?
No, you go 2 and 9.
2 and 9. So we have 8 times 3 minus 4 times what? 3 square root of 2. Now what am I going to do?
24 minus 12 square root.
Okay, at this point, what do I do?
Nothing.
I do nothing. That's as far as I can go. If I ran out of radical signs in one of my terms, then it's just going to be part of the answer. You're not going to be able to combine those things, so that's what you end up with.
Really have to
Okay, so that's radicals. You'll have more and more fun with those as time goes on.
No. Line parallel.
Parallel, lines parallel. What do you know about parallel lines?
They're
Parallel.
They're parallel, yeah. They never intersect. They never cross.
That's them.
Okay, so
Okay, that was a good one.
if I have,
So, who was it?
if I have a line there, and I also have another line there, and I say that they're parallel,
You can't
what am
really
I
make up
saying?
Their slope is the same.
Those ones will intersect at some
No, I said they're parallel,
Their
sorry.
slope will be
No,
the
they
same.
don't look
Wrong.
parallel.
I figured this out.
Because this one's going
Okay, thanks Elias. We'll fix it later. Let's pretend that they're parallel. All right, if that's the same, Tommy, what do you know about those two lines?
They have the same slope.
They have to have the same slope. They have the exact same angle. They have to. Okay? So if that's the case, and I tell you that the slope of this is, well, give me a good estimate of what the slope is.
2
Yeah, it looks kind of like 1. I mean, that's a good estimate. It's going uphill, so it's positive. You stay here and you go up 2 over 2. Yeah, you're kind of 2 over 2. Therefore, the slope on this one also has to be 1. It is.
It is tall.
Leave my lines alone.
Lines have feelings too.
There's an hourglass.
How do they know?
All right, so let's say that the name of this line is 2y minus x equals 2. What I'm interested in finding out is, what is the name of this line if they're parallel?
The same to y minus x equals 2.
No.
Except, what is that last number? First of all, let's put it in slope-intercept form.
Oh, I see what you mean now.
Okay, so there it is in slope-intercept form. The slopes are the same, Zach. What will always be different?
Where they cross the line.
Yes, exactly. Where they cross the y-axis will be different. They cross at different places. The only time the slope and the y-intercept will be the same is if they're the same line. One line on top of another. All right, those, Elias says they're not parallel, but they sure as heck are not on the top of each
And
other.
they
So,
definitely don't cross that one.
Those are
No,
actually
that's okay.
rays.
raise.
Oh gosh.
They are.
Okay, so if I tell you that the equation of this line is 1/2 x plus 1, can I find the equation of that other line given the information I gave you?
Yes.
No.
Maybe try to do it.
You don't know. You don't know if this line is where it is up here. I mean, it could be anywhere here. As long as it has the same slope, it could be anywhere. So I have to give you a little bit more information to lock this line into place somewhere. So what I'm giving you now is a point that this line goes through. So it goes through 1, 2, 1, 2, 3, 4. So it goes through our point 2, 4. So now I've given you a point it goes through. That locks it into one place. There is only one line that goes through that. And when you get into calculus, we'll talk about how important that is.
We'll talk about how there's really more than one.
Yeah. Yeah, it's really interesting. Calculus students will say, so don't we have to do it this way? And it's like, no, not anymore. You're in calculus. Don't. What do you mean? We have the radical. We have the radical in the denominator. We can't do that. Yes, you can. You're in calculus. It's like the rules don't apply to you anymore. Okay, so we go through point 2, 4.
Domestic relations.
in order to find that equation, we do our y equals mx plus b, because that is the formula you use for a line. We know that our slopes are the same, so our slope for this new line is that. What we're interested in finding out is the b. So that's our next point that we're trying, our next place that we're trying to find. You're always trying to find the slope, you're always trying to find the b. We've got the slope. So now we're going to take our 2 and our 4 and put in for our x and y so that we can find the b. So our b is 3. So this equation is going to be y equals what? 3. Oh. So, same slope, different y-intercept. In fact, different y-intercept than my graph actually has, because my graph is not parallel, right, Elias?
I thought you said twice parallel.
Okay. So I didn't go over a ton of equations, but it's the, let's make a new word, the parallelicity of two lines.
It's like the second time. A weird word.
Parallelicity.
Oh, this one's 22 minutes.
We just need to add that with the assignation to that one website.